words, like your favorite color, red, blue, green. Quantitative is numbers, so quality, quantity. A variable can change. Yes, so discrete is something that can't be measured more closely. So number of people, one person, two persons. And then continuous data can be measured more closely. 2 seconds, 2.1, 2.01. So you see in the Olympics, they have it to like 6 decimal places or something. So that's discrete versus continuous. Grouped data. Yeah, it'll be all right for that. Okay. Let's try this one.
So I'm guessing for A1, is it quantitative?
Yep.
And then uh, and for A2, hmm, is it discrete because it ends early?
Length. So length is length discrete or continuous? So can it be measured more closely, or is that just what it is?
It can measure more close. Actually, isn't it? Is that? I'm not really sure.
Continuous. So discrete would be like the number of butterflies would be discrete. One butterfly, two butterflies. It's because you won't have, a half or a quarter of butterfly. Whereas length is continuous because it could be kilometers, but then meters, but then centimeters and millimeters. 0.1 of a millimeter, you could always do it more closely. And B.
Okay, so sorry, I'm not really sure what the class boundary is.
So what this is talking about is these were rounded to the nearest millimeter.
Yeah.
And so you've got 33 up here and 34 here.
Yeah.
And so if it was rounded to 34, what's the smallest number that will round up to 34 to the nearest whole number?
Uh, I don't know, 30, 33,
33 will round to 33.
34.
Nope. It'll have to be, it's like bounds from GCSE, so it'll have to be a decimal.
Is it 34.1?
So that would round to 35. We want the smallest number that rounds up to 34.
33.9.
Can you? So 33.9, yeah. Is there a smaller number that will round up to 34?
33.5.
Yes. And so that's the lower bound. So 33.5. So x is between that. I'm just calling it this x. And what's the upper bound for this group?
Oh, will it be like 36.5?
Yes, 36.5. And you would have to do that for each group for some questions. So, what is the midpoint of this group? How would you do that?
So would that just be the midpoint? Would that just be what x is here?
Well, x is just anything between those two. So, yeah, what would be the exact middle of this group?
35.
Is it 35? I don't know. I'd have to So it's like the mean of the two of them. So you just add them together and divide by 2. And what was it? What is the class width?
I remember class width from like histograms or something. Was that something? Did that have something to do with like frequency or something?
Nope. It is just from 33.5 to 36.5. How? What is that distance?
Oh, is that true?
Yes, and so and you get that by doing upper quartile minus lower quartile. Excuse me. So that was 35. So the midpoint is 35, and then the other one is 3. So you can see when it was rounded, the class width was 2, but when you unround it, it is 3. Any questions there? Okay, that's 3. So I'll use this more in a second. So it's quantitative because it's numbers, quantity, continuous because you can measure it more closely. Class boundaries 33.5, 36.5. The midpoint, that's like the mean of the upper bound and lower bound. Just add the 2, half it, and then class width, upper bound minus lower bound. Okay. Okay, exam question. How about this?
Is the Dayton table continuous because it's not like set, like your weight can vary and stuff?
So weight can be, how would you say it?
Increase.
No. That just means it's a variable. If it was discrete, something discrete might be like shoe size. 5, 5.5, 6, 6.5. You can't be a size 7.3 recurring or something.
Oh, weight can be like exact. Oh, it can be like measured more closely.
Yes. So weight can be measured more accurately. I'm not sure if that's the best thing. So I'll just give an example like kilograms and then grams, and then you could go like, I don't know, milligrams, half a gram. B.
So the class boundaries. So is that for each one?
The third group.
Would that be 44.5 x and then 50.5?
Yeah. And yeah, part 2.
And class width.
Hang on. Let's think about this. These, I think there's no unrounding to be done because there's no gap here. So if we go back a second. So here you had a gap. That one ends at 33. That one ends at 34. But for this one, there is no gap. So if you got exactly 45, you're in the third group because it's or equal to that one. Whereas if you were 44.9, you'd be in the one before. I think it's literally just 45 to 50 if there's no gap between them. Okay, and go on.
And so does that mean the class width would be 5?
Yep.
And the midpoint would be 47.5?
I believe so. So 47.5 kilos. Class width, that's 5. Let's take a look. 45 and 50, 47.5. It is measured and can take any value. Okay, so that's the strict definition for continuous data. So it is measured and can take any value. All right. Any questions about that?
No.
It's all right, I think. Okay. Oops. Let's take a look at this one. Okay, how about this?
Okay, so is the data discrete because you can't have like half a caterpillar or something like that?
Yeah, it can't take any value.
We had a formula for this, didn't we?
Kind of. Do you remember how it would work?
Was it number in stratum over number in population times sample size? Or?
Yeah, that's it. So what would it be for the first group? So it's a total of 204 trees.
And so would it be something like 204 over? Oh, sorry. Oh no, would it be like 78 over 204
Mm-hmm.
times 20?
Yeah. And what is that?
That is 130 over 17.
And SD?
It's like a bad number.
Go on.
7.65.
And so what would you say with that one? If you wanted, because you can't count 7.8, 7.65 trees, can't count caterpillars in that type of tree.
Would I say that it's not good to use or something?
So if you had to check trees,
Yeah.
How many? Hang on. Explain how to take a shot of slide 20 from all the trees. Caterpillars and the lynx caterpillars. You would just round it to 8 trees.
Okay. Yeah.
If you had to, yeah, because you can't do 7.5 trees, and you would just do that for each group, and see.
The type of data, I'm guessing, is that quantitative?
Yeah. Anything else?
Stratified.
It starts. Question C starts there.
Trees. Would it be continuous because it says lengths or something?
Yep. And earlier they said part A was discrete, and so I think what they're getting at for part C is continuous, which is the other side of that coin. Yes, let's take a look. So that one was discrete, and then C was continuous quantitative data. That's good. And then so they did that for stratified sample thing, and their first one was 8, and they did that for each group. Any questions there? That's good. Okay, types of data.
I think that's it.
Yeah. Okay, the large data set. So exam stuff changed, and so now you have to use real world data, and so this is based on weather data. So real world data. So this is, might be first time you've seen it. Collected by the Met Office for several years, and this is just something that you'd have to go through. Daily total rainfall, daily total sunshine, and there's certain things to take into account, like mean temperature. You kind of know where the mean comes from, and you'd have to be aware of that. There's some little weird stuff like knot is nautical mile per hour. It's wind speed over the sea or water. Daily maximum gust, so that would be the maximum speed of the wind, maximum wind speed that day, etc. There's a lot of stuff. And they give you all this data beforehand, and you go through it. Okay, here we go. So this is an extract from the large data set. Let's try part A.
I'm guessing that the quantity.
Quantitative, and anything else you can say about it?
Is that like, I don't know, discrete?
Daily total rainfall. So where is daily total rainfall? So daily total rainfall is measured in millimeters.
Does that make continuous?
Yeah. And so that's something that you have to look at, like what is the unit. I think they just have a tiny little beaker or something, and it just catches the rain as it falls, and they just see how deep it is, and they just measure it with a ruler. So that's millimeters. That's continuous. Okay, B.
Is that random sampling?
Random sampling. Let me just take a look at it. Okay, and C.
It's random, and it might just not get to
5. Might not generate a sample size of 5. Say it again, sorry.
Because it's just a random one. So.
What is this? Daily maximum gust. So that's the last one. Yes. What is this?
I'm guessing that means that the plus is in the minus or something, so there is no gust.
I'm having difficulty hearing what you're saying. Sorry.
Oh, sorry. Could it be maybe like the gust is a minus number? So.
Nope. This is a speed, so it can't be negative.
Is there just no gust?
I think that's it. I think there was where is it here? Daily cloud core. Did I see NA somewhere? Yeah, any missing data values are indicated in the large data set as NA or not available. So for whatever reason, there was no data for that. Daily maximum gust. Okay, so maybe there was like no wind whatsoever, but maybe they'd call that 0. So it's just missing data. Data is missing. This is from 1987, the 10th of June, and so who knows why there's no data. So it might land on NA, which has no data. So she might end up with a sample size of just 3 if she got those 2 in her thing.
Yeah.
Continuous quantitative data, simple random sample. So random sampling, I added in the simple random sample. So the data values are not available. There you go. Any questions about that?
No.
Okay, and so I think, no, it's good. Okay, this thing again. Okay, how about this?
So I'd need to add up 15.1 and the 4 other numbers and divide them by 5.
Yeah, try that. The mean temperature first 5 days in Herne in 1987. Sorry, in June. Yeah. I'm gonna try stats mode. So that would be one variable.
14.
What is it, sorry?
I got 14.
14.0?
Yeah.
Okay, just because they're to one decimal place. 14.0. Okay, B.
I need to get 14th of June to 20th of June in order.
Yep. So the median daily total rainfall. Oh, sorry. The median daily total rainfall. So daily total rainfall is the second one.
Where should I put that TR thing?
I don't know. TR. Total rainfall. Maybe just cross it out. Maybe it's like NA or something.
Yeah. So without TR, my 2 midpoints are 0.1 and 3.7. So do I need to now find the midpoints of those 2 numbers?
Mm-hmm.
So my midpoint is 1.9.
So if I just go to... So I went to menu statistics in the simpler calculator. And I just put them in. So X was 0, 3.7, 5.6, 0.1. So you can see that going down. And I pressed option and then 3 for one variable calc. And I got all these numbers. X bar is the mean up the top. And I pressed down. And you can see lower quartile, median, upper quartile. And so my median says 1.9. And you're telling me 1.9. Looks good. So for simple data, that works. And C. So hold on. I don't know what your geography is like. I wasn't born here. I don't know anything. Hearn, Perth.
That's in
So here's Hearn down here. Oh wow, Perth. So Perth, yeah, Perth is Australia. So Australia is southern hemisphere, and so Hearn is in the northern hemisphere. Okay.
okay. So so conflicts drinking. Yeah, that is right based on our answer, I think.
So our answer was 1.9 millimeters.
Yeah.
Um, and then his one was 19. Say the reason. Yes. So Perth had way more. 19.0 is greater than 1.9. Let's take a look. I hope so. So that one was 14.0. That was the mean. The median is a value, is the middle value, so 0.1. They put TR in. They included TR. Okay. 1, 2, 3, 4, 5, 6, 7. All right, so you do include TR. There you go. I don't know what TR means though. Hang on. This is rainfall. I think I remember. TR stands for trace. That's it.
Okay.
So it's a number that's very close to 0. Is that right? Let me check. Maximum cost. Yes. Amounts less than 0.05 millimeters are recorded as trace. So if it's half of 0.1, so it's very close to 0.
Okay.
There you go. That one got me before. Okay, so we should have said 0.1, but and I can't put that in. I have to put it in as a 0 or something. And then for the third one, Perth in Australia, so 19 is greater than that. However, this is a very small sample from a single location in each country, so it does not provide enough evidence. Okay, so the sample size is too small to say that, because this is just, to make a judgment about like entire southern hemisphere versus entire northern hemisphere. This is based on 2 weeks of data back in 1987, so maybe it was just very rainy those 2 weeks.
Yeah.
All right, any questions there?
No.
Tricky. And so part of this large data set is about like real world stuff, like kind of understanding real world stuff. Okay, let's try these.
Okay. So a sample size. So what was home was just in the south of England, wasn't it?
Yeah,
And Heathrow's like southwest or southeast. Sorry.
I think it is. Yeah. So yeah, Herne is south, and then Heathrow south east. It's a bit higher up.
Yeah.
Okay.
Um. So for choices of location, could you say like that they seem to near to each other, or
Yes. So part two, her choices of location. Um, they're too close to each other. Not enough variation.
yeah,
And part one.
she's only done it for two areas. She hasn't done it for like enough towns to really know how much sunshine changes the further north you go.
So two towns only. What about the number of days?
Um, 5 days might not be enough.
Yeah, very small sample size. 5 days might not be enough. Part B.
Could I use the could I use that formula again? Or
Can take a simple random sample. I think you're thinking of stratified sample.
I just need to put the calculator thing going on.
How would you go about it?
We'll have to do it, but I remember there was some sort of calculator thing you could do to get random.
Yeah. So they're just kind of asking for the steps in general. So simple random sample. Also, as we see from the large data set for Heathrow. So let's say number each data set number each piece of data 1 to 15.
Yeah.
Data 1 to 15. Generate. Oh no, sorry, not 1 to 15. There's a lot more. Each piece of data. Generate 15 random numbers using a calculator, and then select the ones that come up and see.
So this is wrong because it'll give her the same sun.
I can't hear you, sorry.
So is it wrong because it'll give her like a different average and stuff because she's getting sunshine like twice.
Yeah, well, it's definitely wrong. Explain why this is wrong. I suppose it'll give a smaller. It's effectively a smaller sample size, or a biased sample, or a skewed sample, or something. And how could she correctly generate her sample?
By getting the correct day.
Like, if she's using a random number generator and it's like numbers from 1 to 1,000, and it's like 1,000 days, she might accidentally get the same number twice. 137, and then lots of other numbers, and 137 again, and she just kind of didn't realize it. So how could you
she like laid out like, on a piece of paper the numbers 1 to 1,000. She kept on crossing them off. She got.
So I think so. She could cross them off as she went. I think she could use like a lottery as well. So if she did them 1 to 1,000, and once you take it out, then you can't get it the same thing twice.
Yeah.
But I don't know if they want to do that. Let's take a look. Okay, so 3A, yeah, our sample size was too small. It uses two locations that are almost the same latitude as each other. Yes, so they're not far enough apart. She can assign each date a number and then use a random number generator to generate 15 dates in the sample. Okay. The sample should contain 15 different dates. Data values cannot be reused. She should therefore reject the repeated value in the random number generation and generate a 16th. Okay, so it's like what you're saying. That's not too bad. I thought it might be more. Any questions there?
No.
Okay, good stuff. Let's see this one. Lukers and Camborne. I don't know how it's pronounced. Okay, so Lukers, is it up in Scotland maybe? And then Camborne, so up north and down south, southwest, northeast. Oops. Okay, how about this?
Could I say something like because Lucas is in the north, whilst Campbell's in the south?
Yep. B.
Oh, can I just say that 5 days is like a small sample, and he should, and to improve it, he should like just use more data.
Yep. Small sample and increase sample size. Let's take a look. Lukers is further north. The sample size is very small. He should increase the sample size. Great. Nailed it. Got both of them. Let's see this one. Okay, how about this?
Is that just by just doing 20 days of rainfall and leaving, or?
But which 20? How does she go about selecting them?
Oh, could you do like a random sample for the year? I'll just do 1 to 365 and then 20 random days. Oh no. So does that mean they have to be like in a pattern or something?
Yeah.
Could you divide 365 by 20 and then every X amount of days is from the data?
Yeah. Let me just get a feel for this one. It's close to 400. Oh, what's wrong with this thing? So 440. So it's approximately every 20 days.
Yeah.
So that's approximately every. Well, let me just. No, it's closer to 360 divided by 20.
It's 18.25.
Okay, so let's say that's roughly every 8. So that's 18. So and the trick for this one is you have to start at a random point.
Right.
And then you do that one and every 18 afterwards, and you loop back around. Okay, part B.
So B is trace just like a really small number.
Yeah. I think it said if it's less than 0.05 millimeters. And C.
So I'd just say that more I should treat them as if they're 0.05 or something.
Yeah, that'd be a good one. You could treat them as 0.05, or treat them as treat them as 0, something like that. Any question? Oh, hang on, let's take a look at this one. So generate a random starting number and then count on every 9 dates. Aha, so there was only 184 days for that one. So we have to actually have the large data set in front of us to get that one. Let me just see, 184. So the notation tr means trace. Mars method is not suitable as she has discarded data values. So she finds that on several days she discards these readings. So that's what we did. We just left it out of our median, but actually I thought it was not available, but it's not the same as not available. It's actually close to 0. Any data value given as trace should be recorded as 0 for the purposes of carrying out any calculations. Okay, so 0 or close to 0. Yep. Any questions there?
No.
Okay. Let's see this one. Check deep.
So well, it must have been incorrect because you can't have the daily mean wind speed for randomly chosen days. Because wind speed and gust are the same thing, aren't they?
Yeah.
So you can't have the maximum below the average.
Yeah. And B.
So what Beaufort scale?
The Beaufort scale. So that's the. We have to go back for that one. The correct value is in fact 11. Convert this reading using the Beaufort scale. I saw this. Yeah, Beaufort scale. So it was actually 11. So what was that on the Beaufort scale?
So also just before.
So that's 4. Okay, so when I do my sailing, this is what they tell us. And they don't bother with numbers like that. They just say 4 or 5. If it's 5, you're not allowed to go out. And so we are saying this is 4. Let's take a look. 4, moderate. Okay, daily maximum gust must be greater than or equal to the daily mean wind speed. I think you did great there. Let's see this one. Okay, Beijing, Perth, and Herne. Which is which?
Okay, so I'll assume that Beijing's probably. I think Beijing or Perth will be location A.
Was that?
I'm assuming that either Perth or Beijing will be location A,
And why is that?
because I know that in Australia and Japan it's quite hot.
Okay, I didn't know that. I'll take your word for it. Let's see. Oops. Put that there. That there. So I think it's hotter the closer you are to the equator.
Yeah.
So Perth is the hottest one.
Yeah.
So that's okay. And then any idea about the other one? You've got Hearn, which
Yeah.
would be,
Location C, I think, and then Beijing A.
so Hearn is the coldest one, and then Beijing is A. So let's take a look. So Hearn, Beijing, Perth. Hearn was, so A, B, C. I have no idea. Wait, so Hearn and Beijing are just swapped, are they? No. Why? Why statistics? Why must you do the real world? Definitely my least favorite of all
Yeah.
worlds. Let's see. How are we supposed to know this? I don't know. Southern. So, what are they saying? Beijing is B. Beijing is hot because it's. So, Beijing is there. You would think so. That's nearly the North Pole. Perth. Is this even to scale? Yeah, let's hope that one doesn't come up.
Yeah.
Hearn, Beijing, Perth. So B is Beijing. So that's definitely the outlier. So the windiest one is. So A and C are very similar. And that's Hearn and Perth. Yeah, that's one for the philosophers.
Yeah.
I'll let the geography teachers teach that one. Okay, this one. Systematic. So we did A is okay. Any idea about B? Why would she not necessarily get 30 data points?
Is it because she's not measuring the entire year?
No. If she's taking a sample of 30 from those 184 days, why might she not get 30 days?
Maybe because. Oh, is it because maybe for the 184 consecutive days that it might not be windy? Like, all the time.
Yeah, and how is that reflected in the data?
Um, oh, might have an NA or something like that in data.
Yeah, and so they give you a separate thing with all the all the stuff in it, and you just have to look at it, and it's on like an Excel spreadsheet. There may be missing values because the data is not available, and then the other one was just a normal systematic sample. So large data set. What do you give yourself there?
Um, Maybe a tick.
Yeah, I'm sure you'll be better than me. Okay, let's see. Statistics. So population is everything. Census measures everyone and all of them. Individual units are sampling units. Okay. Sampling frame is like an ordered list of all the stuff. So that might be if you give them, each one of them a number or something like that. Each person a number. Simple random sample, that's okay. Systematic sampling, that's okay. Stratified sample, that's okay. Quota sampling was when, they have to meet a quota of a certain number of people, so they just keep going until they get them. Opportunity sampling, so it's just the first number of people that they meet, something like that. What is qualitative and quantitative data?
So it's qualitative, like more opinion. Quantitative is like numbers and stuff like that.
Yeah, so qualitative could be words or something. Discrete and continuous?
Discrete. So it's discrete when like it's like shoe size where you can't have like a 7 and a third shoe size.
Mm-hmm.
But you can have that in like a length or something like that. So millimeters would be continuous.
Yeah. What would they say? Discrete can't take any value.
Yeah.
But continuous can take any value, and it's measured, they say. Continuous, discrete, classes. Yeah, those class boundaries. That's fine. Let me go back to the thing, 'cause this becomes important for the next one. I want to keep that. I think I made a mistake. I'll have to keep that. 1 sec. I think I forgot to include this one last time. Types of data. Yes. Why did we have to extend this data to class boundaries?
Because they'd only given us like two like little values. They hadn't given us like a midpoint and stuff like that.
Nope. Let's say for this one, the class boundaries were 45 to 50. For this one, they weren't 34 to 36. They were 33.5 to 36.5. Why is that?
I'm not sure.
It's because there's a gap.
Okay.
So they rounded it to the nearest millimeter, 32 to 33, 34 to 36. So there's a gap. So if it was 33.4, it would be in the second one. If it was 33.8, it would be in the in the third one. And so you have to kind of unround it, and yes, and you use that a lot for like estimated mean, estimated median, and so that'll be important for the next chapter. Why was the class width for the third group not 2, 34 to 36?
Not 2. Because it's 33.5 to 36.5.
Yes, and so the class width will actually be 3. And what was it? Midpoint. Yeah, you're good for midpoint. That was okay. Just want to make sure. Stratified sample. That was okay. Types of data. Yeah, it's good. How was that for you, Andrey?
Yeah, that's good. Thank you.
So we're back to the good old days of. So we finished that chapter, and so do you want to do chapter 2 stats next time?
Yes.
Okay. Any questions for me in general?
Are they like basic like demographic principles I can learn or something like that? So any of those sort of questions come up.
Yeah. So what's kind of important is the knowledge of it. So the first chapter of mechanics is kind of similar to this. So every other chapter in stats is going to be like the usual type of maths. Like every following chapter for mechanics is the same thing. Like lots of maths. Follow some kind of formula. The first chapter for stats and the first chapter for mechanics is like this, where it kind of just explains where it is and kind of what it's all about. The problem is if you skip it, then you're just kind of, you know, playing pretend numbers for the rest of the stats. But you're not really kind of like, why do we do this? Well, we do it because it's continuous data, you know, and that's it. But this type of stuff, yeah, like a lot of it, you can just kind of learn it. It's quite different from the normal stats. And the same with mechanics. It's quite, the first chapter is quite different from the rest of it.
Yeah, yeah.
Any other questions? All right. Well done, Andrey. You did great. I look forward to chatting again next time.
Okay, thank you. Bye.
All right. Have a good one. Goodbye.